My name is Samuel Eji. You can call me Uncle Sam. I am your facilitator for mathematics at the JHS level. Last week, we looked at linear equations and solved questions on them. In fact, there were various of them, various types. Equation which involves only whole numbers, equation involving fractions, equation involving brackets, and we looked at the rules, the general rules that we may need in order to solve these equations. Assignment was given. I've received your answers. Most of you did very well. Few of you had challenges, but all the same, kudos to all of you. At this moment, I want us to go through the expected solutions of the assignment given. So question 1, as they appear on the screen. You have 8 minus a equals 5a minus 3. The instruction is you have to solve for the equation. I told you, anytime you have to solve an equation, it means you are solving for the variable in that equation. So the first question was 8 minus a equals 5a minus 3. So as usual, that equation does not involve fraction, neither does it involve brackets. So the next step is group like terms. You group like terms by transposing terms to either the left or right hand side. Good. So with my solution, I intended to group like terms, those with the variable a on the left hand side of the equation, and then the constant terms on the right hand side of the equation. So on my left, I already have negative a, the negative affect the a as well. Then another a term is 5a, so bringing it to the left hand side becomes negative. That is by transposing the positive to the left hand side becomes negative. So it's negative a minus 5a equals the negative 3 on the right hand side. Now the 8 on the left hand side, when it is transposed to the right hand side, becomes negative because it was positive on the left hand side. So when it is transposed to the right hand side, it becomes negative. So now, I get negative 6a equals negative 11. Since we want a, you divide both sides by the coefficient of a, which is negative 6. So my a is equal to 11 out of 6. Or you can change to mixed number, that becomes one whole number, 5 out of 6. Let's move on to question number 2. 8x minus, into bracket, 2x plus 4 equals 20. With this one, it's an equation which involves brackets. So whenever an equation involves brackets, as usual, you expand. You expand to remove the brackets. So first I have to expand the brackets. Now the negative before the bracket affects whatever is in the brackets. So by expanding, I have my 8x already there. So the negative, when it multiplies the 2x in the bracket, becomes negative 2x. The same negative, when you multiply the positive 4, becomes negative 4, or equals 20. Then from that point, I'll group like terms by transposing terms to either the left or right hand side. In my situation, I decided to group the terms with the variable x on the left hand side. So I have 8x minus 2x on the left hand side equals, then on my right, I group the constant terms. Already I had 20 there, so I maintain a 20. Then the negative 4, which was on the left, when it is transposed to the right hand side, it becomes positive 4. So it becomes 8x minus 2x becomes 6x equals 20 plus 4 becomes 24. Since I need x, divide both sides by the coefficient of x, which is 6. And then I'll get x equal to 4 because 24 divided by 6 is 4. Let's move on to the third question. Third question is n out of 2 minus 5 or equals 2. Now this equation involves fraction. And whenever an equation involves fraction, as usual, you look for the LCM from the denominator or denominators, that if there are 2 or more fractions. In this equation, the fraction is only 1 and the denominator is 2. So therefore the LCM is 2. So I'll multiply each term of the equation by the LCM, which is 2. So this implies, so the first term From my left is n out of 2. So n out of 2 times the LCM, which is 2, minus 5 times LCM, which is 2, all equals 2, which is for the right, also times the LCM, which is 2. So by simplifying, I'll get n, because the 2 will cancel the 2 in the bracket, then I'll be left with n minus 5 times 2 is 10, so I'll have negative 10 there, or equals positive 4, because 2 times 2 is 4. So from here, simply put, I need my n. So I'll maintain the n on the left hand side, and then group the constant terms on the right. On the right, positive 4 was already there, I'll maintain it. Then transpose negative 10 to the right hand side, it becomes positive 10. So by simplifying further, we have 4 plus 10 giving 14. So therefore my n is equal to 14. Then the fourth equation, m out of 4 or plus 2 equals 3 out of 2. This is also an equation which involves fractions. The fractions are 2 here. We have m out of 4 and then 3 out of 2. The denominators are 4 and 2. So the LCM of 4 and 2 is 4. Good. So I multiply each term of the equation by the LCM. So from my left, the first term, m out of 4, times the LCM, which is 4, plus the next term, which is 2, times the LCM, which is 4, equals 3 out of 2, which is also a term, times the LCM, which is 4. By simplifying, 4 cancels 4, we left with m, plus 2 times 4, which is 8, and then 2 cancel 4, we get 2, then 3 times 2, move on, get 6. So from the grouping like terms, we group the constant terms on my right. I group the constant terms on my right hand side. So maintain the m on the left hand side. M is equal to positive 6. Since positive 8 is transposed to the right hand side to become negative, then becomes m is equal to 6 minus 8. So 6 minus 8, definitely negative 2. So m is negative 2. Move on to the last question. The last equation is an equation which involves both fractions and brackets. Fractions and brackets. So first deal with the fractions. So look for the LCM between 3 and 5, because those are the denominators, which is 15. So each term is multiplied by LCM, which is 15. So from my left, I told you anytime there's a bracket, although in the bracket there may be 2 or more terms, because we have a bracket and there are some numbers outside, multiplying it, they are seen as a term. So 2 out of 3 into bracket k plus 2, all are seen as one term, multiplied by the 15, which is the LCM, plus the next term 2, which is 1 out of 5, all times k minus 4 in the bracket, also multiplied by 15, equals 7 out of 5, also times 15. When you simplify, 3 will divide 15, 5 on my left, and then 5 will divide 15, 3, and then 5 will divide 15, 3 on my right, which is after the equal sign. So from there, we expand, because we've now gotten rid of the fractions. Now we are left a bracket, we expand. So from here, 5 times 2 is as usual 10, 3 times 1, 3. So 10 times q is 10q, 10 times 2, positive 2 in the bracket is 20, plus 3 times q gives us 3q, and then 3 times negative 4, don't forget, we are expanding, that will be negative 12, or equals 21, which is 7 times 3. So from there, we have expanded the brackets, now we have whole numbers. We group like terms by transposing terms. I decided to group the variables, the terms of the variables on the left hand side. So 10q was on my left, I maintain it. 3q, which was positive, also on my left, I maintain them. We are done with the q family. Now the rest are constant terms, so I'll group the constant term on my right. But on the right hand side, we already have 21. So I maintain the 21 on the right hand side. Then transpose negative 12, which was on my left to the right hand side, to become positive 12. And then positive 20, which was on the left hand side to the right hand side, to become negative 20. So by simplification, 10q plus 3q is 13q, equals 21 plus 12 will give us 33, minus 20 will give us 13. Since we need q, we divide both sides of the equation by the coefficient of Q, which is 13. So therefore, Q is equal to 1. Q is equal to 1. Good. All of you did well. So kudos to all of you. Now let's come to today's agenda. Our objective for today's lesson. By the end of the lesson, learners will be able to translate word problem to linear inequalities and vice versa. Today we are looking at linear inequalities. Good. The clear distinction between linear equations and linear inequalities is the signs of the less than, the greater than signs. Linear equations deals with equal sign, the equal to sign. Linear equation deals with the equal to sign. And the equation that deals with the less than, the greater than, the less than or equal to, or the greater than or equal to signs, they are what we call linear inequalities. So what is linear inequalities? Any numerical statements which involves any of the following signs: less than sign, greater than sign, less than or equal to, greater than or equal to, is a linear inequality. So on the board, that is the less than sign. That's the greater than sign. Less than or equal to. Greater than or equal to. Yes, let me stress on this too. Less than or equal to. The equal to is due to the bar under the less than sign. So anytime you see any less than with a bar under it, the bar signifies that it is both less than or equal to. Less than or equal to. The same applies to the greater than. When you see a bar under the greater than sign, it is greater than or equal to. So the bars under them signifies equal to. Now, at times, we use this word at least and at most. It's very important. The less than or equal to sign also means or stand for the phrase at most. At most. Now, let's come to a real life situation. If mommy or daddy should ask you, Akosia or Kwame, there are some oranges in the kitchen. Go to the kitchen and bring me at least 3 oranges. What does it mean? It simply means that you have to go to the kitchen and pick 3 or more oranges. You can pick 3 oranges or more. So at least goes with greater than or equal to sign. Go to the kitchen and bring me at least 3 oranges. It means you can pick 3 or more. That is greater than or equal to. The equal to means 3, the greater than means more. So at least goes with greater than or equal to. Now, the other way around. Mommy tells you, Kwame or Akosia, go to the kitchen and bring me at most 3 oranges. At most 3 oranges. What does at most mean? At most means that you can go to the kitchen and take 3 oranges or less. At most, you shouldn't exceed the number your mother has given you. You can even decide to pick less than that amount or exactly the number your mother said you should go for. That is at most. So at most is used for less than or equal to. So this is at most. So it means that during our lesson, as the lesson goes on, I'll be using these two interchangeably. So if I use at most, then you should know that I'm referring to the less than or equal to. At least, then I'll be using the greater than or equal to. Hope you got that. So we are going to look at how to write mathematical sentences from word problem. One can write mathematical sentences from word problems involving linear inequalities. Just as we did in the linear equations, always denote this unknown number by a letter or variable. Okay, so from here we are going to solve, or we are going to write some examples of mathematical sentences from word problems. Let's look at some examples. You have to write mathematical sentences involving linear inequalities from the following word problems. So the first word problem: 5 subtracted from a number is greater than 10. 5 subtracted from a number is greater than 10. Do we know the number? No. So always denote the unknown number by a variable. So the first one, 5 subtracted from a number. Let the number, I am solving myself, so I'm going to denote the number by a variable. So let the number be 1. I've denoted my variable. Now, coming back to the statement. 5 subtracted from the number. So I'm going to subtract 5 from y. How do you write that? Which implies, as I explained this to you, we are subtracting 5 from the number, not the number from 5. So those of you are fond of writing, because you follow the order, you write 5 first minus the variable. Understand the statement. We are subtracting 5 from the number. So that number must come first before minus 5. Good. And then it says 5 subtracted from a number is greater than 10. So 5 which I subtract from this number is greater than 10. So we use the greater than sign in inequality, which is, so this becomes the mathematical sentence for that word problem. 5 subtracted from number is greater than 10. Good. Let's move on to number 2. 8 times a number is less than 88. 8 times a number is less than 88. Do we know the number? No. So we represent the number by a variable. Let the number be, in my case, I'm using my own variable. Let the number be A. A times a number. So A times A, which is 8A. We looked at this from the onset when you're doing algebraic expressions. Good. So A times a number, that's the next step, arithmetic. So the following the question, now the main word problem is A times a number is less than 88. So the whole of this is less than 88. 8 times a number less than 88. So this is the mathematical sentence for the word problem. 8 times a number is less than 20. Hope you are getting this. Let's move on to the third example. Listen attentively. A number divided by 9 gives greater than 2. A number divided by 9 gives greater than 2. Do you know the number? No. I'm going to choose my own variable here. So let the number be x. Now I have my number, which is x, represented by the variable x. Say a number divided by 9. So vertical form. Sometimes some people write in horizontal, like this. They are the same. But I prefer this one because this one looks more easy to solve with. So a number divided by 9 gives greater than 2. So simply put, a number divided by 9 gives greater than 2. We are done. So this is the mathematical sentence for that word problem. Good. Let's move on to the fourth one. 11 times a number is at most 110. 11 times a number is at most 110. Do we know the number? Let the number be Q. Times the number. And 11 times the number, which is Q, that will give us 11Q. Now, this 11 times the number is at most 110. At most. Which of the signs are you supposed to use? That's what I explained early on. Which of the signs are you going to use? At most means you cannot exceed that, but it can be what? Less than or the same number. So 11 times a number is at most 110. Or, in other words, you can say 11 times a number is less than or equal to 110. Pay attention. If 7 is subtracted from 6 times a number, 7 is a constant term, subtracted from 6 times a number, the result is at least 17. So since you're talking of a number, let's represent the number by a variable. Let the number be P. Let the number be P. I've chosen P as the variable. Now, coming back to the word problem. 7 is subtracted from 6 times a number. So let's deal with the multiplication. Because if you follow the principle of odd mass, yes, if subtraction will be the last thing to do. So let's finish the multiplication. 7 is subtracted from 6 times a number. So 6 times a number, 6 times P. The number is P, so 6 times P, that will give us 6P. So 7 is subtracted from 6 times this. This is how it will be written. So 7 is subtracted from 6 times a number. And the result is at least 17. At least means it can be 17 or more. So the result is greater or equal to 17. Good. Hope you got it. 7 is subtracted from 6 times a number, and the result is at least 17. At least is the same as greater than or equal to 17. Hope you got it. Now, at this point, I will engage you with activity. You have to write the mathematical sentences involving linear inequalities from the following word problems. There are 5 of them as they appear on your screen. Take your phone and snap them where it appears, and then solve on your own. We are going for a short commercial break. When we come back, compare your answers to that of mine, see if you are on course. Stay tuned.
Preview. Preview.
You are welcome back from the break. Hope you are done with your exercises. Okay, now let's compare our answers as they appear on the screen. So the first one was 2 subtracted from a number is less than 8. So this is how I did mine. I chose the number to be x on the screen. So let the number be x. So 2 subtracted from a number is the same as or is equal to x minus 2. X minus 2. Good. So this x minus 2 is less than 8. That's what it means. So 2 subtracted from the number is less than 8. So I use the inequality sign less than here. So x minus 2, the less than symbol, less than 8. Hope you got it right. Good. Kudos. Let's move on to number 2. 10 times a number is greater than 70. 10 times a number is greater than 70. I use the variable y to represent the number. So 10 times the number is the same as 10 times y, which is 10y. Now this is greater than 70. So I initiate or bring the inequality sign, greater than sign. So 10y is greater than 70, as you can see on the screen. That's the mathematical sentence on the word problem. Number 3. A number divided by 5 gives less than 6. What is the number? I chose the variable a to represent the number. So a number divided by 5 is the same as a out of 5 or a divided by 5, as you can see on the screen. So this implies a out of 5 introduce a less than sign, then make the positive 6. So a out of 5 less than 6. That's the mathematical sentence of that word problem. Hope you got that one to correct. Kudos. Number 4. 7 times a number plus 7 is at least 88. So in this case, you know the number? No. I represented the number by the variable of my choice. I chose Q as a variable. So Q represent the number. Now 7 times the number plus 7. So 7 times Q plus 7. As you can see, now we have 7Q plus 7. Good. All of this is at least 88. That means it can be greater or equal to. So at least goes to greater or equal to. So 7Q plus 7 is greater or equal to 88. Hope you got that one to correct. Good. Let's do the last one. The last one we have. If 6 is subtracted from 6 times a number, the result is at most 30. So as usual, represent the number by a variable. I chose R, or I used R in my case here. So let the number be R. 6 times a number the same as 6 times R. Now 6 is subtracted from 6 times the number. That means 6R minus 6. 6r minus 6, because we are either subtracting the 6 from 6r. Good. All of this is at most 30. At most means it can be less than or equal to 30. So this implies 6r minus 6 is less than or equal to 30. Hope you got all correct. Clap for yourselves. Done really well. Now let's go to the other side. We looked at how to write mathematical sentences from word problems. Now, on the other hand, we want to look at how you can write word problems from mathematical sentences. Just have to take the linear equation. It's similar here. The only difference here is over here you are making use of the less than, greater than, less than or equal to, and then the greater than or equal to symbol for signs. Good. So one can write word problems involving linear inequalities from mathematical sentences. Always note that the letter or variable represented in linear inequalities is the unknown number. Yeah. So let's look at some examples. So the instruction is write word problems involving linear inequalities from the following mathematical sentence. So the first one, we have x plus 3 less than 5. X plus 3 less than 5. And the solution or the word problem for that, I will 3 more than a number is less than 5. 3 more than a number is less than 5. You can choose to write a number plus 3 is less than 5. It's still correct. Or the sum of a number and 3 is less than 5. It's still correct. Let's move on to the second one. We have 4y minus 2 all greater than 18. So I wrote 2 subtracted from 4 times a number is greater than 18. 2 subtracted from 4 times a number is greater than 13. You can write it in your own way. Let's move on to the next example. Good. You have 2 out of 3, a plus 1 less than or equal to 1 out of 2. So I will 2/3 of a number plus 1 is at most half. 2/3 of a number plus 1 is at most half. Good. So you see, always when you see at most, then you should know that it's less than or equal to most. The fourth one, we have 3 into bracket q plus 6 bracket close greater than or equal to 36. Good. So this one I wrote 3 multiplied by the sum of a number and 6 is at least 36. 3 multiplied by the sum of a number and 6 is at least 36. So you see the 3 outside the bracket is multiplying the sum of q and 6. You see, and it's at least always stand for greater than or equal to. Good. Then the fifth one, we have 7p minus 5 or less than 2p. So I wrote 5 subtracted from 7 times a number is less than twice the same number. Yes. 5 subtracted from 7 times a number is less than twice the same number. Good. So at this point, I want to engage you in some exercises. Write word problems involving linear inequalities from the following mathematical sentences. So there are 5 of them as they appear on the screen. As usual, you can take a snapshot before it disappears. Make sure you solve all these questions. We're going for a short commercial break. When you come back, compare your answers to that of 9. See if you are correct. Stay tuned.
Preview. 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 Preview.
Welcome back. So let's look at the solutions. So the first one, we have 7p less than 21. So we have 7 times a number is less than 21. Hope you got the same thing. Good. Or you can say the product of 7 and the number is less than 21. Or product means multiplication. Good. And the second one, 5t minus 3 greater than or equal to 7. 3 subtracted from 5 times the number is at least 7. I want you to get used to that. At least. At most. So at least always stands for greater than or equal to. So 3 subtracted from 5 times a number, which is t in this case, is at least 7. Good. The third one, we have 2 into bracket x plus 3 bracket 2 is greater than 8. So 2 multiplied by the sum of a number and 3 is greater than 8. 2 multiplied by the sum of a number and 3 is greater than 8. Good. Let's look at the fourth one. We have 2 out of 3y minus 4 less than or equal to 6. So the one to our root. 4 subtracted from 2/3 of a number is at most 6. If you don't want to use the at least as usual, you can use the less than or equal to the same. So at most is the same as less than or equal to. 4 subtracted from 2/3 of a number is at most 6. 6. Good. The fifth one, the last one, you have 9 plus 2q greater than or equal to q. So that one too. The sum of 9 and twice a number is at least the same number. Yes. Why am I using the same? Because the variables are equal, the same variable. Just that one is on the left and the other on the right. So the sum of 9 and twice a number. Twice means 2 times. So the 2 times kill there. Or someone can, the sum of 9 and 2 times a number is at least the same number. Or the sum of 9 and twice a number is greater than or equal to the same number. Good. We are about to end our lesson, but before we go, I'll give you an assignment as usual. Now, pay attention to the instructions of the assignment. So at this very moment, I will entreat all of you to take a snapshot of the assignment before it disappears on the screen. Write mathematical sentences involving linear inequalities from the following word problems. So 1 to 3, that's what we are supposed to do. We are coming up with the mathematical sentences. Questions 1, 2, and 3. So the first one, 4 subtracted from twice a number is at most 2. The second one, thrice a number divided by 4 is at least half. And the third one, the result of doubling a number is at most 16. That's the first part. And the second part, you have to write word problems involving linear inequalities from the following mathematical sentences. So the fourth question, we have the fourth one, we have 3 in bracket x minus 2 bracket close greater than 15. And then 21 minus t less than or equal to 11. That's the fifth one. And the sixth one, we have 2y greater than or equal to 3 minus y. Good. Hope you enjoyed the lesson. This is where we draw the curtains for today's lesson. My name is Uncle Sam or Sama Eji. I look forward to having another quality time with you. Bye for now.
Preview. 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 Preview.